Just a couple of notices before we get going. I mentioned the CSTA, which is Computer Science Teachers Association. It's an international organisation. It's a part of what's called the ACM, really. Oh, who knows what ACM stands for?
Association of Computing Machinery.
Association of Computing Machinery, right. I've still got some prizes there. Quick. The Association of Computing Machinery, as you can tell by its name, has been around for a very long time. I think they just had their 50th anniversary. But it is the international organisation that people like Andy and I and Tanya belong to as our professional organisation. So, sort of for computer scientists, that's where they sponsor conferences that we go to, and there's just thousands and thousands of computer scientists who belong to that organisation at the university level. But just a few years ago, they started up a high school level equivalent, which is the CSTA, and in fact its web address is csta.acm.org. The thing about the CSTA is that it was to encourage teaching computer science in high schools, which in America, and as far as American-based organisations go, that's the entire world. It's very few states have any kind of computer science available in schools in the way that we do. And there's just a few pilot programs going on, so they're very interested in what we're doing here. But they have got a lot of resources, mainly oriented around sort of saying, we assume you aren't really allowed to teach this in your class, but here's some activities you can do, and that sort of thing. And, but they send out newsletters and ideas and that sort of stuff, and it's all free, so it's good to join. The membership thing kind of threatens that you might have, 1 year that they might have to start charging membership, but they sort of say informally, we never want to do that. It'll always be sponsored by someone, and anyway, you can just resign if they start charging. How many people are a member of the CSTA? Okay, so I'll pass this around. If you're not, then grab a form and fill it out, and although it's got an address on the back to send to America, if you just leave them all down at the front here, we'll collect them all and send them in one envelope to the CSTA. And just two other quick things. I mentioned very briefly before about some textbooks, so I'll leave these down the front just to peruse, but this one, Designing with the Mind in Mind, it's just a good informal read about HCI. And this one here, it's actually by a guy called Ben Schneiderman, who also visited us a few years ago, actually, and works with Andy, designing the user interface. Way more detail than you'll ever need for teaching the standards. But if you've got a bit of spare time and want some interesting reading about why these things are a pain, it's another very approachable book. They're more about psychology and how people think it is about sort of technical stuff. And then the other one, which unfortunately both Andy and my copy are locked away because we're out of our offices while they're being repaired. But it's a really nice read. It's called The Design of Everyday Things, which is the one that he put up before. And it's just got all sorts of stuff about doors and car controls and telephones and things like that, and why people get frustrated with them and what's wrong with them. And it gives you kind of gets you to that culture of looking at interfaces and thinking about what's wrong, rather than just going, oh, stupid door. So I think that's all the announcements for the meantime. And a question? Oh, here's more of those. I'll bring some up the back. Yeah. Pass those around. And so, it's a great pleasure to hand over to Anthony. Each university has one person who's kind of been nominated as a local rep for people for local teachers to come and go to. And Anthony's put his hand up very early on for being the person for Otago down in Dunedin. And he's also been quite involved in helping comment on and work with some of the developments with the standards, which has been very helpful. And the other key person in the universities has been Peter Andre, who many of you may have seen him posting on the NZDIT site and so on. He's actually overseas on study leave at the moment, so he would have been here otherwise, but we didn't actually get everyone. But all the other universities have kind of got a representative, but those are the three universities that have kind of been representing the others. And so Anthony and Peter and Andre have particularly taken an interest in programming standards more so than me. So I'll let you do the programming standards thing.
Thank you very much. there's a couple of handouts that go with this talk. I hope you got one of each. One of them's on just a printed copy of the standards themselves, and the other's a summary of an example that I'll spend quite a bit of time talking about, because the example is very helpful. So if you don't have a copy of either of these, pass these around. That's the standards, and this is the example. So just pass them around to people who look interested. If you're not doing programming, I'm sorry, this is going to be a fairly torrid hour and a bit for you, because a lot of people regard this as the dry, technical, hard stuff, which it is, but it's also the really exciting stuff, because once you can write a program and take control of the computer for yourself, you're not a user anymore, you're liberated. You're in charge of the game instead of just doing what other programmers have set up for you. So who am I? I'm Anthony. I've been teaching, well, my original background is in psychology. I'm a graduate of this university in the early 1980s, and by odd routes I ended up in a computer science department. I've always been much more interested in people and the brain than in computers. But I've ended up teaching programming and teaching introductory programming, and I've become very interested in it. I've become very interested in why so many of my students fail in my introductory programming course and what I can do to fix that. So my interest in psychology has led me to study the psychology of computer science education, what's going on in people's minds when they learn their first programming language. So that's my academic background. My involvement with schools is a long one. I'm from a family of teachers. My sister's a teacher and PBTA activist. I've spent time on the school board of Logan Park High School in Dunedin and on the curriculum committee, so I learned to see schools and the curriculum from the teacher's point of view. Both my kids have just been through NCEA, and for the last 6 or 7 years I've been teaching programming in schools, teaching programming for Lego robots. I've taught a little bit of Alice very early on to intermediate school students, and I've also taught lots and lots of students programming with the Lego Mindstorms robot kits. So I have a little bit of hands-on experience with high school students, so I want to thank and congratulate every high school teacher in the world, because it's a hard job you do. I get the good students come to me at university. You guys deal with a much more diverse range of ability and behavioural issues, I have to say. So I hope I've got some appreciation of where you're coming from. I work on this stuff with Sandy. I've been teaching introductory programming at Otago since 1990. Sandy joined me in about 1999, I think, as the teaching fellow for our lab. So I present an introductory programming course in lecture format. And she does the actual hard work in the lab together with students, which I only do very occasionally when a demonstrator breaks an arm or there's a snow day and nobody else can get in, and then I have to show up in the labs and do my thing. So Sandy and I work together a lot on programming, and in particular we've been working together on a resource workbook, which many of you are receiving, and which I hope, if you haven't heard about it, I've got some copies here you can have a look at if you might be interested in. And it's supposed to be a resource to try and guide people through the programming standards. We're writing to level 2 because level 2's upon us next year. We intend to write to level 1 and level 3 also if we can. It's very much a work in progress, and we do hope to improve it, and we're looking forward to feedback about how we can improve it. So, the standards, I'm going to be talking about 145, 146, mostly 245 and 246, because as I said, they are the ones that are coming up, and they have some more technically challenging content than the 100 level, than the level 1 standards. I should say, please interrupt, grab my attention at any time, ask questions, whatever. I have a tendency to talk unless stopped, so stop me every now and again with questions, because it's much more important that you ask your questions than I keep running through my pre-programmed script. So, let's see. This is good. Hello, hello. I usually have a little remote for this. Okay, so I'm going to talk about start off with 245 and 246, the coming level 2 standards, and I'll talk about why they should, in my opinion, be taught and assessed together. Why, in my opinion, each on their own is difficult to assess or to run. So I'll compare them side by side and show the similarities in structure of the 245 is the planning one, 246 implementation and coding, and then I'll work through each one individually, kind of looking at the step-ups, what it takes to move from achieve to merit to excellence in each of these standards. Then I'll have an example, and I expect we'll probably spend longest on the example, and I hope we'll get plenty of questions and discussions of the example. It's based on what might be a realistic kind of task to set a group and to assess them on. And it's the second of the two handouts, so working through the standards, you'll need the first two handouts, which is standards and record forwards. When we get to the example, you'll need the one labelled simple hangman. And I've got a disclaimer at the top of that which says, I am not school teacher, NCEA, expert or ministry official. All of the following is my unofficial opinion. So these are not approved teaching standards from the ministry. Heaven forbid I should dare to speak for the ministry, or they for me, just incidentally. So these are my examples, and I've constructed them in a way that it lets me bring out different kinds of issues that I think might actually emerge in the classroom in interpreting exactly what it is that a task means, and in looking at different kinds of indicators that will help you work out or assess form a judgment as to this piece of work, is it achieved merit or excellent standard. So that's the point of the quite detailed example that I hope we get to spend time on. And then I'll speak more briefly, probably much more briefly, about the level 1 standards, because as you're probably aware, they've just been revised after their first year in use this year. They were revised and they now in structure resemble the level 2 standards quite significantly. They address less programming material. There's some issues that we address at level 2, mainly iterated data structures and modular structure, procedures, subroutines, functions. Those exist in the level 2 content and not in the level 1 content. But other than that, the structure of the first year standards, the level 1 standards, is now very similar to the level 2 standards. If there's time and or interest at the end, I could talk about the use of robots as a teaching tool for teaching programming. And I, in perhaps some other forum, can go on any length required on the psychology of teaching and learning programming, which are the issues that really fascinate me. Okay, any thoughts, questions or problems? It's a standard phrase that trips off my lips during lectures. Any thoughts, questions or problems so far? Yeah. So, the dreaded matrix, just so we situate ourselves with it, that's obviously completely illegible, but we're digital technology. We are going to be starting off with 245 and 246, which changed their names, or 245 changed its name in particular. Once again, along with the level 1 standards, we've dropped the terminology of algorithmic structure, and we're now allowed by the ministry to talk about developing a plan for a program. Apparently, when the first draft of these standards was written, the language of a plan was deemed to be not acceptable, and so the writers of the standards tried to work around this term algorithmic structure, but in practice that hasn't worked out very well, and so the ministry have allowed us to go back to using the language of plan. A lot of what's problematic or difficult about the standards comes from constraints imposed on those who are trying to write a group to which I have a lot of sympathy, because you work in a tightly constrained world. So the achievement standards starting off with 245 and 246. 245 is construct a plan for an advanced computer program for a specified task, and 246 construct an advanced computer program for a specified task. So if I was to put my own language on that, my own language is in red. You've got to understand the task and you've got to map out a plan for a program. And then in 246, you've got to take a given plan and implement, code the program and test it. So, I would, if it was me, always teach and assess these combined, because I think there are 4 major reasons why one would want to do so. First up, there are 2 aspects of one process. The real process of writing a program means going round and round this loop. You start off with trying to understand what it is you're trying to do. And if you don't get past that point, you can't write a program. You can't write a program until you know what to do. And then you plan the program, and then you implement and test the program, and you find, oh, that didn't work. Oh, the language doesn't let me do that. The language has this really neat feature that makes that much easier. And maybe you do some testing and say, whoops, I got that wrong, I got that right. So now you've got a new situation. You've got to understand the program that you've actually written, and your new understanding of language features that might or might not be useful. So you update the plan, you implement the approved version of the program, you do some more testing, maybe find a few remaining little niggly issues, you understand those, you update the plan, you implement and test. And eventually you get tired and stop when the program's done. So you go round and round. This is a complete development cycle. The standards cut it in half. The standards put understanding and planning into 2.45, and then they ask you to assess a finished plan. To my mind, that's quite a difficult thing for a student to do, because they've had no chance to implement the plan and test the plan. It's hard for me to imagine how a student can know if they're particularly good or not. Likewise, 2.46 is under the blue line. That's take a plan, you implement and test it. Like again, there's nowhere in the cycle for revising the plan, improving the plan, and developing the program further. So, if it was me, this would be a major reason for always bringing 2 of these things together, because that cycle, I believe, should not be split. It should be experienced and assessed as a cycle. The second reason why I think it's good to treat these together is that it's a chunk of new stuff. It's seriously difficult and or easy for different groups of students to learn programming. But for a large chunk of the class, it's a seriously difficult thing to learn. And 30 hours for the content of either 245 or 246, I believe, would be challenging. You've got to learn a lot of stuff to learn how to program, and I'd rather have 60 hours to do it than 30 hours. There's a lot of conceptual overlap. The standards aren't supposed to assess the same thing, and they don't. One's about a plan, one's about a program. But a for loop is a for loop in the program, and you learn about it, you understand it, and then you can use a for loop in a plan, and you can learn about it and understand it. There's a lot of conceptual overlap between the plan and the program. So if it was me, I'd want 60 hours to assimilate this material and work with it, rather than 30 hours working on what is effectively a lot more than half of it. Another couple of reasons I would like to do these things together. I would find it difficult myself to assess 2.45 on its own, because I believe it's hard to accurately assess a plan. Now there are some example plans that we'll get to with the simple hangman problem, and I challenge anyone to spot the deliberate error which I've incorporated into the plan, which means it's a broken plan. Actually, no, I haven't. But reading through a plan, I can't read a plan myself and tell whether it works. I've got to have a program to test. And more to the point, I don't know how a student would assess for themselves whether or not their plan is a good one. Whereas assessing a program is easier. It runs, it has behaviour, it does the right thing, or it doesn't. Likewise, I would find doing the implementation, the coding standard on its own, quite difficult, because there you have to give the student a plan. And my question is, what plan? Is it an achieved plan, a merit plan, or an excellence plan? Because those are 3 very different plans. And the language of the standard is that we're supposed to supply an abstract plan. Explanatory note 6 in 2.46. Explanatory note 6. Specified task. It is expected that most students constructing a program for this standard will have developed a plan for advanced computer programming for this task. That's as close as the standard authors could get to saying, please, 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 do 2.45 first. Because if you don't, if this is not the case, the teacher should provide the student with an abstract plan to guide their program development, but one which cannot be directly transcribed into the programming language. Okay, so what is an abstract plan? I can't tell you. I would be challenged to take that on as a teacher. Alright, so that's why I believe these standards go together. Any questions or issues so far? Okay, then let's start, yeah.
One of the points that was expressed as a reason for doing them separately was that it was, at level 1 anyway, was that it was then lower stakes and that kids that couldn't do the planning could achieve the other one. If you combine them, then that ceases really to be an option and kids are either going to pass or fail the whole
I agree. Which is why if I was doing this as a teacher, I would use one of the generic standards as a backup, as a plan B. If a student was obviously not coming to terms with this material to assess as the programming standards, I would have one of the generic standards adapted and I would switch them over to some lesser set of goals and I would see if I could give them some credit for that. Yeah.
As a student who achieves at achieved level 2, 4, 5,
yep.
They would be limited to achieve level 2, 4.
Yes, if you're doing them lockstep together, yes they would. Or you might decide that having assessed 2.45, you can give everyone in the class an excellence plan, which you can do under the system, and see if that can give excellence in the programming in the 246 standard. That's possible under the system, but I put it to you difficult. If a student wasn't capable of developing a plan to excellence level, I don't know if they're capable of understanding and coding an excellence level plan. I really don't. Yeah?
Just a thought, as a teacher, if you have got a class that's doing these two standards together and you take the ones who are struggling and give them another set of work, you've now doubled your workload. And
if you give them a what?
You've doubled your workload in terms you've now got to have a separate group of students who are only coping over here, another set of work, another set of material to prepare, another set of sort of lessons and background and help and so on. It's very hard to keep that many balls in the air at the time as a teacher.
So I missed the point. Is that if you use the generic standard?
Yeah, that's what I'm saying. If you're finding someone who's not going to pass the 2.45 and you say, hey look, in that case, let's give them a generic standard instead. It just seems to me that now you've got to try and deal with a lot more things as a teacher, and it's really quite tough keeping up this, let alone trying to keep up with split classes that have different things going on with different goals, with different standards.
Sure. I actually haven't looked at the generic standards in detail. This was a conversation I had with one of the ministry people.
Yeah, they aren't teachers either, so for them it's just, I'll just do that instead. Yeah. But it doesn't work out to be that easy when you're actually trying to deal with kids and classroom management and materials and new assessments and all sorts, to suddenly chuck another ball up in the air as well and say, don't worry, keep juggling, it's easy.
But the other thing is the issue of timing too. I noticed that you're saying it's better to have 60 hours rather than 30. I counted up the hours in our school year and there's actually 132 teaching hours in my year 11 and year 12 classes. And if you, we're planning to do 19 credits, well that's basically 7 hours per credit. So you actually don't end up, you end up with more like 42, not 60. And I know that you've got that old, gee, it's prior learning, it's homework, but hands up anybody who actually manages to get their kids to do homework on a regular basis. I can't talk to you about
Both ways of splitting fiction together have their advantages and disadvantages. At least we have the ability to choose one or the other. And we could have ended up with a 6 credit standard that had them both together. So, although it is difficult now to choose the perfect way to do it, it's going to be a blend of having to give up some things to get other things. But at least we've got a choice. And we can say to a kid, look, totally blown the plan, take my plan and try and get the second part. Or we can say, the program is such, why don't we focus on the plan and try and fix that? So it's not ideal, but it's better than one.
I think the ministry is quite aware that these standards have a bunch lumpy introduction. And not only is the level 1 standards had an early review, but I expect that the whole package will get another early review. And hopefully by then everybody will have experience with it and you can tell us how they should work instead of standards designers trying to guess. I myself am firmly in the 1 standard 6 credit camp because I don't think academically it makes sense to separate this material, but if teachers tell us practically what they want, hopefully we can get through what you want. Let's carry on and look at these 2 standards kind of side by side, just to see the patterns and similarities between them, how they map into each other. So 245 and 246, starting with some of the explanatory notes. 245 is all about, let's skip over that, a plan, which is some document communicating the structure of functional program, which must be developed in the context of a target programming language. That's in there because some programming languages have different features for others. Some make some tasks easy, some tasks hard. It doesn't make sense to plan for a programming language feature that isn't there, or to plan and ignore a really useful programming language feature that you could have used. So a plan is situated in a target programming language, and then in 246 they describe a programming language must be text-based and must support various features, index data structures and modules. That's the stuff that's in level 2 and not level 1. And then parameters, different scope of variables, and comment and documenting facilities. Explanatory note 4 in both of those is identical. It's about an advanced, well, actually identical except for the dots on EG. No idea.
Just back up, sorry, on 246.3, must support index data structures. Is there a comma in there? Comma, modules with...
There probably should be, yeah.
It's me.
Okay, so an advanced computer program must have a modular structure, an index to data structure, an array or list, input and output, procedural structures that combine sequential, conditional, and different structures. So it's basically loops and if-else, case statements, switch statements, if you like. So you're planning for this, you're creating a plan, which is a description of the program, and then you're implementing it, and they're tightly tied together in terms of what you're working on. They're also tightly tied together in looking at the step-ups across the 2 plans. So this is achieved, comparing achieved to 245 and 246. The key word is construct, and then of course merit is skillfully, and excellence is efficiently. So we're constructing a plan, and we're constructing an advanced computer program. Just looking with a bit of sort of colour here to see the map. In 245, we're trying to specify variables, scopes, and data types. We're specifying index data structure, that was a requirement for the task we work on. And we're specifying a modular structure, so we've got to use procedures, subroutines, functions, methods of some kind. All of those, in the planning stage, map into implement a plan for advanced programming language. You've got to implement the plan, and the plan has to have these kind of features. There's some points which are the same across 245 and 246. You've got to plan your testing for a set of expected input cases, and then you've got to test and debug the program to ensure that it works on expected input cases. So what are expected cases? This language comes up with it. If I want a range of inputs, say from 1 to 10 inclusive, expected inputs fall in that range. 2, 5, 9 are all expected inputs. Boundary inputs are 1 and 10, and the numbers on either side, 0 and 11. So those are all the boundaries of what I'm interested in. An illegal input is F, or hello, or just hitting return without hitting any number at all. So this is what we mean, these phrases come up quite a lot. Yeah?
Is 2.0
Yeah,
expected legal or illegal?
Very good question. If it's expressed like that, it kind of implies integers, and you might expect 2.0 to be an illegal input. Actually, if it's expected, the program specification might say in the range 1 to 10, real numbers in the range 1 to 10, which is 2.0, or it might say integer numbers in that range, in which case 2.0 might be illegal.
If it was an illegal number, would you expect the program to just initially compute or tell the user, please put this? of the test variables that we put in rather than 2.0,
Yep.
but by doing the cast in the wrong place, the program fell over, and it became quite a difficult problem to deal with for something that I would have expected to be easy.
Yep, a lot of programming is like that. Programming is the pickiest thing a human can do. And it's all about detail, and the more you field test the stuff and try it out and catch these potential issues early on, the better. Yeah.
So for, let me see if I get this right. For achieve, if they identify that it falls over, mirror is some kind of attempt to fix it. Number E would be.
As we work through, what we'll see is that in general, achieve have got to cope with expected inputs.
Yeah.
Merit people should cope with expected and boundary.
Right.
And excellence, if you can cope with all three, it's an indicator of excellence.
Is there any easy way of finding problems with your program, like some kind of validator?
It depends on the program. Some tasks, by their very nature, won't have much input. The task I'm going to show you, which is an example hangman program, doesn't have much input. It's quite easy to systematically test every possibility. Programs that are more data-driven, that might not be an issue. If you're really good, you might write testing suites to test programs, but it's very hard to take something off the shelf because every program's different. So in general, I'd say no, unless somebody else here knows of tools. There aren't any automated tools for testing programs.
It's just that I'm quite new to programming, and I wouldn't really know a mistake that happened.
Well, this gives you some guidance. Look at boundaries, because things that are off by one error are common in loops and array bounds and so on. It's easy to go one further or one not quite far enough. That's a common kind of error, and handling illegal inputs should always be at the forefront of your mind. Users, I mean, we've all had a good laugh today at interface designers, because interface designers give us lousy interfaces, but as users, we do some pretty whack stuff as well. And you've always got to expect your user to push the wrong button or no button or give you some strange input. Yeah?
Just another question too on the expected and boundary. Is one not an expected boundary?
It is, but it's also a boundary.
So you could have it in both lists?
You certainly could.
Yes.
So just to clarify for the boundaries, perhaps, in Excel you make a statement and you're working out between the ranges of all those under 15. Often if you put the wrong number in, it comes up with everyone who's 14, 15, 16, but they don't actually 15 when you actually meet 15. That's the boundary kind of question you're actually talking about, isn't it?
Question, I mean,
Yeah, and then the kind of error that comes up.
Less than or less than. I mean,
Yeah.
And there's an example of that in the hangman program where exactly that error makes a real difference to the program. Okay. All right, so looking at these, and then there's some criteria in the programming standard which can only apply to code. Is your program code set out clearly and documented with comments? That can't apply to a plan, so it's present in 2.46 without any corresponding indicator in the plan. So that's at the achieved level, comparing the two standards. At the merit level, it's all about doing stuff skillfully. And here, once again, we've got a mapping. In the planning stage, we're trying to work independently. That's a big indicator. When the student doesn't require constant hand-holding to get through, they're working somewhat independently. That's a huge indicator, at least it would be for me, that they're working above achieved level. Are they specifying well-chosen scopes for the variables? Bad design is to have just everything a global variable. Good design is to have variables which are local to a module, declared and used locally in the module. Are they sending the right information to the modules as parameters? Are they sending too little, too much, just the right amount? And at the planning stages, all of those map into one bullet point in the programming standard, which is, are they independently implementing the plan that has those good properties? Once again, there's the same 2 points about testing. We've now expanded our testing from expected to expected in boundary cases to deal with at this merit level. And once again, there's an issue which applies to code but not to plan, which is is the program code set out nicely, and now we're talking about things like variables and modules have sensible names, that are not called everything X and G, which gets really annoying after a while, and have they got accurate and useful comments that describe the code, functional behaviour. And finally, at the excellence level, it's about efficiency, which I find a problematic word, but it seems we adapt it to the context, and we make do. And here the correspondence is more direct. We're trying in our plan to efficiently specify modules that constitute a well-structured logical decomposition of the task. Now there's an explanatory note that tries to guide us through that, but basically an achieved program works, a merit program works and doesn't do anything horrible, and an excellence program works and does nothing horrible and is maybe even well designed. And that's this well-structured logical decomposition of the task. So we're after that in our plan, and then in our program we're trying to actually implement such a plan, a well-structured, well-designed plan. Other bullet points in 2.45, we're trying to specify variables, constants and derived values so as to maximise flexibility and robustness. This is about not hard coding things. If I've got the length of an array with some stuff in it, I don't want to hard code that length as 10 and then write 10 in my program code everywhere. Because later on I change the way I try to explain the task. That array now holds 15 elements instead of 10. I don't want to have to go back through the code and change all the 10s to 15, because sure enough I'll miss one and the program will break. So we're looking for planning of basing the behaviour not on 15 or 10 written in the program code, but on the length of the array, which we measure and use.
A great one around that has been the change of GST.
Oh yes.
How many people program 12.5 hard-coded into their program
Yeah.
and suddenly had to go through and change it all to 15?
It all makes work for programmers. Yeah, and so the same thing is reflected in the plan, in the actual program. Have a program that has this property. Again, there's an issue which applies only to code. Now we're asking for comments that explain and justify decisions. A really good programmer will not just say what they did, but they'll say why they did it, what the alternatives were, and why they chose this alternative over that one. Because that's the most useful information for the next programmer that picks up this project and works on it. And we've now got our testing clause expanded to cover expected, boundary, and now exceptional. What to do when the user inputs F.
I think we just need to explain that justified decisions. It doesn't mean the conditional decisions. No. It's the decisions of what code you actually do.
Yep.
So
Good
just
point.
be aware of it.
Yeah. Okay.
Just a question?
Yep.
The last point there.
Yep.
I know what they mean, but the last statement around ensuring the program is correct on expected boundary and invalid inputs is
Yep.
actually entirely unlikely. You can have reasonable confidence, but I don't think you can have that certainty.
Well, if only, you probably can for simply.
Every permutation and combination of logic in the program?
Well, no, well, you can't prove that every program holds. That's true, and there's a lot of maths and science around that.
I just think the kids are challenged in that respect. They've got to do enough comprehensive testing to have reasonable confidence. They can't test
It is within reason, and it's not in the standards themselves, but in the supporting documents that I've seen for the standards. There's language about teachers' holistic judgment, and that's what it really should be all about, because you can make these checklists until you're blue in the face, but in the end, you've got to combine and weight and make a holistic judgment. Okay, so that was the standards compared side by side, planning and implementing. Now we'll just have a look at each standard individually at the step-ups within that standard. So this is the step-ups within the planning 2.45 standard. I know you can't read that, you're not supposed to read that, but we're constructing, skillfully constructing, efficiently constructing. Again, here's the mapping into more legible web text. At achieved level, we're specifying variables and an indexed data structure. At the merit skillful level, we're doing that independently, and we're putting the variables in the right places, giving them the right scope. Not everything global, not everything, things declared within methods and modules, if that's what they're supposed to be. and at the excellence efficiency level, we're specifying these variables. We're making some of them constants if we can. If it doesn't make sense for a value to change, indicate that, make that as constant if you can. Use derived values, use the length of the array rather than a hard-coded value like 15. We're trying to maximise flexibility and robustness of this level. Other mappings in these step-ups. At the achieved level, we're trying to just specify a modular structure. We're trying to have at least, one or two methods, functions, subroutines, call them what you will. At the merit level, we're trying to send them the right information, send them well-chosen parameters. And at the excellence level, we're trying to have that with a good overall design, this well-structured logical decomposition of the task. Not only if they use the module, but it's a module that makes sense in the context of the task. It handles a distinctly identified subtask, maybe something that occurs quite often in the program. It makes sense to create a module for them. And finally, in these step-ups, the testing ones, testing the expected input cases, the expected and boundary input cases, and the expected boundary and exception input cases. So that's just within the planning standard, and tracing through the step-ups in the implementation 2.46 standard. Once again, we can trace a progression through. We're trying at the achieved level to implement the plan for an advanced program. We just get it done, get it working. At the merit level, we're trying to do that independently, and we're trying to build in these properties of well-chosen scopes for the variables and well-chosen parameters. And at the excellence efficiency level, we're trying to have well-designed modules that capture sensible chunks of the task, reusable chunks of the task, and we're trying to use our variables, constants, and derived values to maximise flexibility and robustness. Then there's stuff which relates only to code and not to a plan. Am I using some comments? Setting up the code clearly using some comments. Am I giving stuff useful names and also providing useful comments? Or am I providing thoughtful comments that are about the design of the program and what the design alternatives were as I step through it? And then finally, we've got our testing step-ups again. Am I testing expected boundary, and invalid? So that's a real comparison of the two standards side by side and systematically through each. Question?
So, third one down, efficiently. So, organise some time. This was a time effective way.
Yep.
So it's easy to test the boundary cases. The testing of the data for it is easy part, but how would you test the effective organising time way?
That's going to apply more to some programs than others. In my little example Hangman program, it uses so little input that it would be a very difficult point to assess, frankly. If you were doing something like Tim's data sorting example from that, he was ripping apart phone books up here, that's so cool, I wish I thought of that. You might have different, hugely different size files that we need to work with, files with 1 number, 10 numbers, a million numbers. How are you going to organise that process? How are you going to create the test data? It becomes much more of an issue how you organise your testing if you're working with complicated data-driven tasks like that. For example, it would be a very bad idea to create a data file with 1 million items in it by sitting there and typing them in. You want some kind of program to generate test data in that case, and that might be a very simple program to just fill a file with random numbers, much more organised and time efficient than trying to create it by hand. That sort of issue for some kinds of programs, but not so much for others. Anything else? Yes.
Yeah, we evaluated that against how students tested the high end of boundaries. So they, the ones that knew what they were doing could set the variable to 999 and then test it as an increment for 1,000 rather than, oh my god, we've got to run the same down.
Yeah. That's that kind of thing.
That's time efficient.
Good. Okay, we might have reached the point there where we can look at an example. And this is the simple hangman, which is the second. I do want to stress again, this is not a ministry resource, this is just my constructed example. It's badly constructed in some ways because it allows some issues to emerge, but I think that the issues are realistic ones, and I hope that it will be useful to look at some, both some plans and some programs for this task and consider their implications. So I'll actually run the task first. Which we'll do first. Okay. So one. This is a game of hangman. Now I, of course, formatted all this for a certain screen resolution, and then plugged it into the projector, and the projector reset all my screen resolution so everything looks whack. Sorry about that. Nonetheless, welcome to Simple Hangman. You will be asked how many games you want to play. In each game, I choose a word and you try to guess it one letter at a time. One letter at a time. One letter at a time. In each game, you only get 12 incorrect guesses. I'm not actually going to draw out the gallows, but I'll tell you how many guesses you've got left. Please enter the number of games you want to play from 0 to 3. Let's have suggested inputs from people. Try and break my program. Yeah. 0. That is a what case? It's a boundary case. Thanks for playing. Goodbye. Is that useful behaviour? I don't know.
Thanks for not playing.
You could prove that, couldn't you? The program didn't break, however. Yeah. Anyone want to try a different? Sorry? 10. Oh, no.
-1.
-1. -1. Oh, that wasn't an integer. We actually spotted the illegal one. Okay.
TWO.
TWO? That wasn't an integer.
1.5.
1.5. This relates to the integer boundary thing. That wasn't an integer.
2 divided by 2.
Oh no, I'm not gonna do real time input parsing.
Right on 3.
Right on 3?
Yeah.
Oh, 3. Right, let's give it 3. Let's have 3 games. Welcome to game 1. I have chosen a word for you to guess. Please enter a single letter. Bother it again. This is not going to look pretty on my screen. Hang on, I'm going to create some more screen real estate. What? You guys have guessed it already. You guys are so good. No, it's not going to let me go bigger than that. Okay, M. Amazing. Try me again. E. 3. Good.
Happy.
Capital A.
Very good.
M.
Look at that. You have already guessed that letter. Please try again.
S.
Sorry?
S. It's capital S.
S
is
Mississippi. Anyway, yes,
if S is in the word,
yeah,
the capital S came up with the error.
that's right. You'll see in the task description it says assume lowercase for everything, because making it handle both cases would have made it a little bit more fiddly. So I just ruled that out. Comma. Small s.
You don't lose the sharing function.
So lower is, so we would tell us we have to enter lower case.
In the task specification.
Yes?
It's good for the user.
The word is Mississippi. Congratulations, you have guessed the word correctly. Welcome to game 2. I've chosen a word for you to guess. E. X. A. Brilliant. There are only 2 words that this program knows. I tried.
X in Mississippi.
It's not X.
In fact, I'm just going to run this one out to make sure that that behaviour is correct, and that when we get to the end of the guesses, 0 guesses left. Sorry, game over. The word was Mississippi. Thanks for playing. Goodbye. So that was actually an excellence level hangman program because it handled expected inputs for both number of games and letters. It handled boundary number of games, we tested that, and it handled illegal number of games. The question of whether or not it handled boundary or illegal letters is actually quite fuzzy. What is an illegal letter in a hangman game? Is the same letter twice illegal? I ruled it out in this program. But is entering 2 illegal? That's a wasted guess because it's not a letter, so I didn't rule it out. Is it an illegal or boundary? It's fuzzy. This is real world fuzzy. And with the sort of issues that might come up inadvertently, you might write a task which you think is perfectly clean and pure and simple, and then you'll get some user program which is interpreted in a way you didn't think of, or raised an issue that you didn't think of, and you have to decide. Yeah.
What does it do with hyphens and apostrophe?
What does it do with hyphens and apostrophes? Let's find out. Let's run it again.
Did you write the plan before you wrote the code, or did you just start writing code?
I said, now I write the code. This is my first ever Python program, incidentally. And I wrote it to learn Python. It's such a simple program that no, I didn't write it first. Which is...
And that's one of the real world and real teaching problems. And it's like the equivalent where you're doing sorting, but you're only sorting 8 or 10 things. You know, what you actually find out by sorting 8 or 10 things is different from, you know, sorting 1 million. But the programs that we have to write are so simple that no programmer would ever actually do, you know, a diagram or a flowchart or whatever. They would simply spin in and start coding. But what we're trying to teach is different from what
There's a different from an experienced program writing program. I'm not a great programmer. I'm a very average programmer, but I am an experienced programmer. So I sit down and I start coding because the plan of the program is the same thing for me. But when you're learning, it's different. For a learner, it is good to plan. And we see this time and time again in our labs where we have a space in the workbook for the plan that they're supposed to develop before they come into our labs. Those that plan have an easier time than those that come into our lab and start typing. Yes?
When I'm teaching things, I actually get 7 Ps, which is proper prior planning for these difficult points.
Yeah, love it. Yeah. I've got a kind of a simpler take-home little homily which I like, which is, what is it, that 10 minutes in the library can easily save you 2 weeks in the lab. You know, it's just planning, thinking first, think before you act. It's in our lab book. The sooner you start coding, the longer this task will take. Plan first.
Does Python know, I'm used to Perl with squiggly brackets to surround the loop. Does it automatically do it on how many tabs you put in, does it?
That's right. Python controversially uses white space tabs and blanks. It has syntactic meaning. There's not many languages that do that. It's a little bit controversial.
It's actually quite cute that Python does it, and I think it's sensible. Although having said that, why do they bother then force you to put a colon in there to say, hey, I'm about to use white space for, you know, if they're going to go for spaces, then go for it whole hog and get rid of the
It
colon.
probably makes it much simpler in the compiler.
Probably does.
For a complex check, they can just do a simple one. Okay, so, but we're not supposed to be looking at the code first. I'm going to hide the code away. We're just playing with behaviour. Okay, so now that you've seen Hangman, take 5 minutes to read the task description and the notes, and then flick over and have a look at the 2 plans. Because there's 2 plans. There's a flowchart plan, and there's a detailed text-based plan. And it would be really good if you could spend 5 minutes looking at those, and then we'll reconvene. Task description and 2 flavors of plan.
better ways of being efficient in your testing, being testing the procedures independently of the rest of the code?
That's a way of developing a program where you write a module. They talk about stubs and drivers, where you write the outline of the module and test the core and return from it, and then you fill in the details and test the values going in and out. There's also different languages have different features. Python actually applies some stuff for automated testing. You can write testing code into your program that will perform certain checks for you automatically. So Python would actually be a nice language for exploring that testing aspect of these tasks.
Sometimes students would do it, they test as they go along.
Yeah.
Difficulty is that they don't always keep a record of that.
Yeah, the teachers I work with in Dunedin are concerned about not overloading students with too much record keeping, but they still have to supply documentary evidence for their plans. It's a practical issue, and I suspect that teachers will fall in different places in their own practice and in their own classroom as to what they require from students. But you certainly don't want to stop them every step of the way and make them take screenshots and write screens of documents before they can do the next thing. Yeah.
If you're using a visual design language like Basic or C#, and the students use the mask text box, that still be...
Sorry, they use the what?
Using mask text box, which takes care of the additional errors.
Right.
They don't have to explicitly code it.
Right. That's an interesting issue because, again, some programming environments automate some stuff and make it very easy and make it go away. You could say that they made the right choice in selecting the right kind of text box to do that testing automatically. You might decide to weight that aspect of the assessment less strongly because they have automated it all for a clever use of text box.
Isn't that efficiently constructing the program?
They are efficiently constructed, yeah.
With the testing as you go, I quite often, they still have to test the final product, but they quite often say, all my testing was successful on the first round because I tested it as I went through and
I think that would be acceptable. I certainly, I test my code as I write my code. The other way.
Small changes test after small,
exactly.
And that's also one of those things, you know, the same way that as a programmer you start coding, you actually always are testing along the way, and you're quite right, it's hard to document every single test you did the whole way. Slide bars are used for entering numbers, so you can put a minimum value and a maximum value in, and then you can't enter values that are outside the ranges, so all of those things suddenly, all you've got is integers that the slide bar lets you enter. So you've done all of that at excellence level by the right choice of the right choice.
So you can certainly argue that does indeed meet the criteria, but in your holistic assessment you might weight that aspect of it somewhat less than you would otherwise working with something like Python where it's all raw. So let's reconvene and let's look at these plans. The flowchart is obviously the simpler, in many ways more accessible plan, and you might get this kind of plan of something which led into an excellence type plan or program, or it might be a finished plan for a somewhat less good planning document because it doesn't have anything in here about the testing and there's very little in the way of comments and explanations and so on. But there's nothing in the specification of 2.45 that says what a plan should be specific. Something like a flowchart could be a very large part of it. How do you assess this and how does a student assess this? Can you tell if there's an error in that flowchart? I would find it hard. I would find it hard to guide a student through saying, well, that's a flowchart, obviously for an achieved program, because that's a flowchart clearly for an excellence program. I would find it hard to evaluate a plan. I can evaluate a program because I can run it and see what it does. The text-based plan, which is based on pseudocode, informally written code, and a lot of explanation around that. This would be a fairly common form of plan. This is a good plan. It discusses in a module at a time, specifying for the inputs, for the modules, what their inputs are, what their outputs are, and how to test them. And then it gives a pseudocode for the module. And it does that module by module, 1, 2, 3, 4, 5. And then it sets out the global variables. This is the issue of scope and defining things in the right place. What are the things that need to be known by all modules? Those things, and only those things, should be global variables. And then it sets out the main routine, a description of what its task is in text, and then the main routine pseudocode, and that assumes and uses and draws on the supporting routines and their inputs and outputs. And again, I could imagine evaluating a plan like this, but I'm quite sure I miss areas of a plan like this because I can't run. I can only look at it and think, yeah, that looks right, or no, that's an obvious thing. Was there another question?
Yeah, particularly with pseudocode, but also with flowcharts, I find the whole retrospective planning thing that the students do leads to the code effectively being mildly reworked. The pseudocode is effectively mildly reworked program. Yep. They paste it and then they just replace the less than with words less than.
Yeah.
At what point do we have to say no? That's not good enough.
I can't tell you that. That's a teacher's judgment in the classroom, isn't it? I recall in one of the drafts there was phrasing to try and deal with that issue, to say that the plan has to be distinct and separate from the program code. I don't think it made it into the final draft, so I don't think at the moment anything rules it out. One way I might manage it if I was in the classroom would be set different deadlines for drafts and things, and have early deadlines for draft plans. Question and then another one.
I'd probably make two comments. One, I think the whole programming algorithm development is quite intrusive. And secondly, perhaps if you're evaluating the correctness of an algorithm, actually part of that is not only your visual look at the algorithm, but actually the program works, because ultimately the algorithmic thinking must have gone into the program one way or another, either in here or on a piece of paper.
Which is why I would find it easier to do both.
Well, a structure diagram allows you to do a desk check of your plan before you run it.
Yep.
So you could conceivably do the first one as a structure diagram, you tested and made sure it worked before you moved on.
Nothing in these ruled out desk checking. Desk checking was in early versions of these standards. It was taken out. It's good mental discipline, I suppose, in the same way that learning Morse code or Latin is good mental discipline, but it's not something that real programmers would do much anymore because it's just so much faster now. Desk checking you did when you had to take your punch cards to the office and wait for 2 days before you got your output back. So it's worth investing in time to hand check. I don't know what programming hand checks and desk checks because your machine's in front of you, it's so much easier to run the check. But again, as an exercise for students, there's no stop teaching you.
I suppose that idea about taking the programming and as long as there's some sort of journal or community that's along the way to show that they've been working in the right direction, you know, it's my responsibility being taken this where I got to really but I think we need to have some documentary evidence along the way.
Yep, I certainly wouldn't disagree with that. If you remember back to my slide that we circling on it, yeah, you go round and round this loop, and if they did quite a lot of implementation that fed back into the plan, that wouldn't be a problem for me because that's realistic in my opinion. Yeah.
One of the ways I was taught to error check was to print out the variables all the time. Yep. Instead of seeing anything like that here.
Yep. That's actually a form of error checking that I use most. I know you can use debuggers and you can do all that symbolically, but learning a debugger is often a task, and sometimes programs behave differently with the debugger enabled and not. The debugger can actually create its own problems. So I'm what I call C vernacular, a printf debugger. I print stuff out when I want to debug, and certainly that's something I want to teach students if I was teaching this.
And they can just comment out those print statements
Exactly.
and leave them in the code so that they can
Or
use
the set one flag, debug on or debug off. If debug on, print. If debug on, print. And then it all goes on and off with one flag. Okay, let's go back to this world here and let's consider a merit program. Here's a merit program for the hangman world, and let's run that. Give me some inputs.
2.
2. Let's play 2 games. I've chosen the word for you to guess. It is 3 letters long. Notice the other one gave me a little picture. Generating that little picture was actually a little bit fiddly, so it's not happening in the merit version. It's only telling me how many letters long. So it's a 3-letter word, so we all know what it was.
G.
Sorry?
G.
G. No, not in the word, 11 letters left.
X.
X. X is in the word. You've guessed a letter in the word in position 1. It's not giving me a picture anymore, it's telling me what position. Computer scientists number things from 0. 0, 1, 2. I found X at position 1. Now, that, in terms of the task description, is feedback about whether the letters are correct and where they are. It meets the task description. Is it useful? Is it helpful? Now, as a player at the game, I'm going to have to keep a piece of paper and write it down myself.
But I'm also going to have to know that the computer programs count starting at 0.
That they should know by this point.
But the player's a game mode. Program will.
The player may not. That's a very good point. So in the task description, and this is one of the things that I deliberately vague, after each guess, the program provides feedback about whether or not the guess is correct, yes, and if so, where the letter occurs in the word, yes. This meets the criteria. But it's a bit hard to use in the excellence programs. That, I think, you could take as evidence that the excellence person had done thinking about the logical decomposition. They've gone into what the task meant and how to represent the task accessibly to the user. Who's got another input for me?
5.
5. Okay, that's not in the word. Yep.
X.
X. Ah, this is good. This is an excellent test. It's in the word, and now I've got 2 letters out of 3 correct.
Oh, let's go for X again.
My gosh, I didn't realise you'd gone to that domain.
I know. Alright, so my excellence program detected duplicate inputs and said, no, duplicate, do it again. This program doesn't do that. So I can guess the same, guess a word by just getting one letter right at a time. Let's do that again. Let's hope we get Mississippi. Play it again, because there's an even better trick I can do. Oops. There's an even better trick I can do. Please enter number of games.
3.
Oh no, hang on, where are we?
Where have you got an Easter egg in it?
Let's try and break it. Let's enter B as the number of games. Oops. B. Whoa! Bang. We're not handling illegal inputs anymore. We've stepped down from our excellence handling of illegal. We're not handling illegal inputs anymore. Nonetheless, let's try that.
Did you say this was a mirror?
I said this was a merit. It meets the criteria. It's a bit rough. But it meets the criteria. Zero. Enter number of games 0. Thanks for playing with that. So that's still the same. Okay. What's going on?
Oh yeah.
Okay. I'll have 3 games this time. I want Mississippi. Okay, I've got Mississippi.
Oh.
Watch this. Watch this. I enter S. I've got 4 letters correct out of 12.
Yes.
No, I'm going to keep entering S, exactly. Now I've got 8 out of 11. And I've finished the game with 12 out of 11 correct.
Alright.
Yeah. So that duplicate letter problem, but at least the program's finished. In my achieved one, my merit one used this for the length of words, so it spotted that I was finished because I was less than or equal to the number of letters in the word. My achieved program uses that. So it merely carries on, and if I keep putting the S, it tells me I've got 15 out of 16 out of 11, 20 out of 11, 24 out of 11, and so on.
And you mean equals only, not less than only.
Yes, yeah.
So, can I just check? I may be wrong with my brain at the moment, but I'm thinking that if I have a student who is busy, if we're all busy making a simple hangman plan, shall we say, and we get a student who gets in at the very end of it and you pass it the grades, you can easily hand them this excellence plan and say, do it from this for the programming component. Couldn't you?
You can at this level.
Yes.
You can when the standards are split. There's nothing that stops you doing that.
Yeah.
The question is, to my mind, if you give that student a very complete plan, they'll get it implemented, but you've got to fight with that explanatory note that says a plan that cannot be directly converted into code. You've got to give them an abstract plan. I don't know what that means. If you give them a plan that's very easy to convert into code, are you doing them any favors? If you're giving them one that's not, my guess is if they couldn't develop it, they also can't interpret it.
Yeah.
My guess. I don't know. Yeah.
I've heard rumors that when they're meaning, what they're meaning is it can't be like pseudocode, it has to be like written out in words.
Sorry, I missed that. There's lots of stuff comes down.
I'm just saying, I've heard rumors, not I don't know any candidate, but I've heard rumors about it being not pseudocode, that it's going to be words.
I certainly.
Purely that those of us who went to Vic and worked with Peter on Ray, he said, look, constructive English is really good, rather than pseudocode maybe for this level. That was just an indication.
Okay, if it's just an indication, fine. If it was a rule that said no pseudocode, I'd have to ask what that rule was for. I'm a fan of pseudocode. I write simple pseudocode sometimes, but complicated program, yeah.
The flowchart here, I went to a thing a couple of weeks ago in Auckland that I've used this in year 11, it's saying style, and we were clearly told not to use the diamond shapes. And is there a rule about that, or?
There are probably one set of rules that says use and one set that doesn't, so pick the set of rules that you like.
So we can use this.
I don't know of a reason why not. There's nothing in the standards that specifies what kind of language you need. Sorry? Yes, I did see that language around somewhere in one of the early versions. All these things like UML diagrams. There are formal planning representations which some teachers might want to use.
The difficulty with that flowchart is the roots are not obvious. It's difficult to work out where the Y or the reach goes in.
Okay, that was a merit level 1. The merit level 1 didn't handle unexpected inputs, it didn't detect duplicate letters, and its feedback was less accessible. It was just a list of positions, whereas the excellence the Achieve program still doesn't pass so long as we give it everything exactly as it was. I'm pushing 5 instead of F5. So the Achieve program it will break on anything other than expected inputs, so even 0 works, but -1 or anything like that will break. Let's actually play some games though. Let's play 99 games. Just at the merit. Thank you. Is there any more? Okay, there's the Achieve one. Right. So please enter the number of games. Okay, 0 will have 0 actually does have now the really extreme form of error which this Achieve program suffers from was a version of the Mississippi problem. It also does no upper bounds checking. So you can have as many games as you like, check scroll down, but not the upper. So a 3-letter word, once again, it should be X, correct position 0, 1, and 2, but nothing stops me from repeatedly entering A, and I've got 3 out of 3. I want Mississippi. I was never going to choose Mississippi because of the program error. Okay, so this one actually has lots wrong with the code, which is creating these kinds of errors. And one of the things that goes wrong in the code, and you have the code for all 3 versions of these, so there isn't time in this session to go through the code in detail, but you can certainly look through the code and look at the comments, which tells you about the strengths and weaknesses of the kinds of error. But one of the errors that this program is that this setting of the random variable is in the wrong place, it's in the wrong scope, and therefore it's choosing the same word every game. So we'll just stick that in there so it chooses a different word every game, and we'll hope that we can get an example of this to run with Mississippi. Let's have 99 games, 11 letters. Okay, so here, if I repeatedly guess S, I accumulate correct guesses, 8 out of 11. I'm up to 12 out of 11, and I'm still going 16 out of 11, 20 out of 11. And that's because I'm doing an exactly equals test for the right number of letters instead of a greater than or equals test, which is more robust. So these are the kinds of issues that might distinguish the different levels of solution. We are very nearly out of time, so I'm not going to step through the 100 level standards, the level 1 standards, but they follow exactly the same structure as the level 2 standards, in that they're clearly connected. The plan and the program go together, they mesh, and the step-ups follow the same patterns and address the same issues, but they're missing modules and they're missing the index data structure.
So do you have a soft copy of this?
I will email soft copies of this to anyone who wants it. I'll put it up on a website, and it will also be incorporated into the work that's in the writing. So I'll make it available.
Just in terms of teaching this, presumably you would work through with the class the whole process of doing this, so they get the idea of the cycle that you go through, and then give them a separate program and say, here's your one, go for it.
I think I've heard of teachers doing it different ways. That would be the way I'd probably do it, but I've heard of teachers doing it different ways.
There's a lot to cover because in fact you've got to teach them all about what's an array, what's a module, what's a parameter, what's a, you know, and that takes quite a chunk of time.
Yes,
in some kids that's real hard going.
I agree.
And then you've got to get them to sort of put that all through that process.
Yep.
And then,
and what it seems to me is that they go through that same process, either for 245, learning how to write a plan for a program, or for 246, learning to write a program. So you might as well have 60 hours instead of 30 to try and do it. I'm supposed to finish at 2:40, which it is now. If I had 5 minutes, I would flip over to something completely different and show you a robotics program. Can I steal 5 minutes, Tim? Yay. Okay.
There's no reason that by separating the assessments you still can't take your 60 hours of learning though. No. It's the assessment time that you're splitting, not the learning time.
But, well, I don't know.
So you could certainly teach the whole thing together and then assess it in 2 chunks.
Yes.
You still have the 60 hours of teaching.
Yes, sure. One of the things, the level 1 programming using Scratch is likely to be quite visual and interactive and graphical. And now we get to these text-based languages, and all of a sudden, where did the fun go? Bother. Now, you can do that. You can use a graphics layer on top of Python and do graphical tasks. You can use a graphics layer on top of Java and do graphical tasks. But it's a whole bunch of extra stuff either way that you've got to learn and teach to get it done. So again, if I was a teacher, I'd be debating, do I make stuff graphical or not? An alternative is to do robotics. This is a 5-minute video made by a group of school students I had. Tago runs an outreach program to rural and disadvantaged schools. I had 8 kids for 2 days doing robotics programming. I'll just run it and you can see what kinds of stuff is going on, because this was all basic text-based programs. But you get to see the behaviour because it's robotics. You actually make a robot do stuff. It runs around. So this is an early version of a soccer playing robot. That ball is emitting infrared light. And the robot has an infrared sensor on the front, amongst other sensors. It's got a compass on the top that tells it which way north is. It should only steer the ball into the goal towards its own north, and it should try and score goals. So I had 8 students for 2 days, and this was the other task they attempted. This is obstacle course line following. That's supposed to follow the black line, take hints from the little green squares sometimes, get over various obstacles. When you go over the ramp with light, your light sensor gets different readings and you think you've lost the line, so you get lost. These are Lego Mindstorms robotics kits, great platform for teaching. They have clipped together in any combination around the computer brick. Powerful motors, sensors of different kinds. These are light sensors on the bottom that he's showing us. They can detect colours, we use that to follow the line. It's got a sonar sensor on the top, which works like a bat's ear, which gives you range to obstacles. This is a soccer program. It's got the infrared sensor, which looks for the ball. It's got a colour sensor on the bottom, which gets position information about the colours of the field. Compass on the top, so it knows which way it's facing, north or south. And this is an example of the kind of code they wrote, simple text-based stuff. C-like programming language, if this, wait, on forward, else, all very standard stuff. He's doing real science. He's calibrating his light sensors off the field, trying to work out whether he's on light, green or dark. He's recording values displayed on the LCD on the top of the thing to work out what reading he gets from different light, different colours on the field, so he can build into his program behaviour that depends on where the thing is on the field. He is calibrating his sensor on the front. That sensor is reading invisible infrared light out of the ball, and it gives you a different number represented in quadrant 7, quadrant 6, quadrant 5, quadrant 4, and the number representing your range, the distance. So here are some nearly finished programs. After 2 days, they've got a line follower, which is fast, smooth and reliable. Getting those nicely calibrated movements is not as easy as it looks. And they get round using their 2 downwards facing sensors to detect the line. This one's going to pick up the green patch and know which way to turn, because green always means turn left. Now this stuff is fun. Kids like this. It's motivating. It's a simple text-based programming language. You could do this for the standards. The only pain, he made it over the ramp. The only pain is that the robots are expensive, about $350 a kit. He's used a sonar to code watch.
600? 600?
No, $350. Toy World in Dunedin.
Wow. Toy World is 600. So.
Yeah, well, shop around.
And what are you doing for your inputs? Testing your expected inputs in the boundary?
That's very easy with robotics, because everything's unexpected and boundary. It will depend on colours and ranges and that sort of thing. This one is trying to find the cam and rescue it, push it out of the green area, which it did with him. Here's 2 finished soccer programs, very dumb soccer programs, but we've only had 2 days to learn all this stuff. And they're chasing around after the ball and trying to score. And really it's quite a pathetic display. Humans have got nothing to worry about yet. It's pretty sad, but we'll finish on a high note with a goal or 2.
What are your arrays? What do you use for your arrays?
Arrays, you could have arrays of values to recognise different combinations, because you get a red, green and blue colour. You can have an array that holds the colour specifications for the different colours on the floor.
So these ones use them?
Did they happen to use arrays? No, they didn't happen to. It could easily make the task do it.
Did you have the robots already built before you got into the class?
I did, because if you let them do it, they spend all their time.
Sorry, I missed that, sorry.
If you let them build their own robots, they never get onto the program.
Right, okay.
We're going to get a goal! We're going to get a goal! Yes!
So what are the kits actually called?
Lego Mindstorms.
Mindstorms NXT.
Different programming IGE though?
Yes. This is the last thing. This is so hard. The maze is a bugger. Nobody gets it in competition. He almost got it and missed the last one. That was as good as we got. That's it. Robots are great.
What language did you use it then?
That was using NXC, not exactly C, but since then my guys have moved themselves to Robot C, which is better.
Thanks, Anthony.